All right, so hopefully as you get done working on those warm-up problems with your group, you can take a look here at the answers from all three of those, just going back over how to use our exponent rules to simplify things down to just one term. And then once we get it down to that one term or a mixed number breaking into two terms, we can then simplify it down to some radical expressions. So you can see the answers up there, just compare with what you and your group got. So getting into day 6, we're going to start talking about the last lesson here in Unit 2, which is complex numbers. So as you look here at this little section, complex numbers are made of a real component, which is always going to be listed first, right? Which we're always going to try to keep first. And then this imaginary component, which is always going to come second when we write out a complex number. So it's always going to be in that format where we have a plus bi, and really that I variable is what makes that second part imaginary. So we talked before about how you cannot have the square root of a negative in an answer. That is not possible, right? Because there's not a number we can take times itself to get a negative value. So here, really, what we've done is represent the square root of -1 with this imaginary unit I, right? So this I variable, it's really just going to represent the square root of a -1, and we're going to use that to try to simplify things down that otherwise cannot be simplified. So starting with example 1, what we really want to do here is get rid of the negative out from under our radical. So as we do that, we're really going to break this down into two different square roots. First, the square root of -1, and then that is getting multiplied times the square root now of a positive 49. So the goal was to get rid of that negative, and from there we would simplify like usual, right? So looking at the 49, we break it down into these pair of 7s, which we're going to move out front. As we do that, this square root of -1, just like we saw up above, that is really going to be represented by our imaginary variable I. So when we bring that 7 out front, really what's going to happen is we're going to throw it in front of that imaginary variable, and that'll simplify all the way down to just 7i, where nothing is left under the radical at that point. We can do the same thing here on number 2. Once again, we want to first get rid of our negative value under the radical by saying -1 times the square root of 90. So once again, we're just breaking this square root of -90 into the square root of -1 times the square root of positive 90. This square root of -1 is what's going to become our I, or imaginary unit, and then we would factor tree the 90 just like we did back in day 1, right? So here you can use whatever values you would like to start it. We end up with our prime factors, in this case, a pair of 3s that we can bring out front. So when we bring those out front, we're going to throw it in front of our I variable. And really, we end up with 3i in front of the radical. Underneath now, if we multiply what was left underneath back together, the 2 and the 5 is going to get us a 10, right? So looking at it, this is really what is considered to be an imaginary term, since it has that imaginary variable in it. So go ahead, try this last one, same kind of idea. We want to start by getting rid of the negative sign, right? So a lot of people, what they'll start to do is recognize that. And we only do this for square roots, right, or even roots. So when we have this even root or this square root based on this index value, what we can do is just take this negative sign right away and move it out front, and recognize that out front this becomes our I variable representing our imaginary unit. So factor treeing the rest of it just like we would. We have 2 times 25. 25 gets broken down to 5 times 5. Gets me a pair of 5s. Here I can see I end up with a total of 3 pairs of x's, and my y does not make a pair. So we're left with a couple things under the radical. In this case, the only thing left under the radical is a 2 and a y. Out front, we're bringing a 5, 3 x's, and there was already a -4 out there, as well as the I that we brought out there. So when we multiply all this together, we end up with -20 x to the 3rd I times the square root of 2y. So as you can see there, all 3 of those, in order to simplify them down, we had to use our imaginary unit. So all those 3 would simplify down to what we would call an imaginary term, or imaginary component. So breaking down what happens when we throw some exponents on our I or imaginary unit. So for the first one, obviously we talked about I just represents the square root of -1. So what happens is, as we get to I squared, really what we're doing is taking that square root of -1, and we are taking it and squaring it. So really these two operations, the square root and the squared, cancel each other out. So really we always say that I squared ends up then being -1. So it's a key part of today, right? So if you want to highlight that, star that, whatever you need to do. We're going to use that as we go further in the lesson. So I squared really always comes out to be the value of -1, whereas I is the square root of -1. Once we get into I to the third, obviously if we wanted to break it down, there we would have I squared being multiplied times I, right? If we wanted to separate it into two separate exponents. So obviously I squared ends up just being a -1 like we just talked about, times I. So really we would say that I to the third simplifies down just to a -I. And then for our last one, I to the fourth now. So I to the fourth we could say is I squared times I squared, both I squareds. As you look back earlier, we said simplify down to a -1. So here really we have a -1 times -1. So I to the fourth really is going to get us a +1. And then really that pattern just kind of continues to repeat for every 4 exponents, right? So once we get to I to the fifth, that would simplify all the way back down to just the square root of -1, which would be the same as I. Once you get to I to the sixth, right, that would simplify all the way down to -1, just like I to the second, really. So anytime we're dealing with these imaginary variables, we're always going to get one of these 4 values in the answer, either the square root of -1, which would be represented just by the I. So really, as we look at it, these I's, right, I, we would just always keep as I. I squared is -1. I to the third is -I. I to the fourth would be a +1. So we're going to use that as we look at these next examples and start performing some operations with these imaginary units. So what's nice about today, we're going to treat I just like you would any other variable, right? So in order to add or subtract like terms, right, you're only combining the things that have the same variable, right? So only the imaginary parts get combined with imaginary parts. The real parts would get combined with the real parts. The only difference is once we get to this multiplication, here's the key, is anytime we end up with an I squared, we're going to replace that I squared with a -1. So let's start with our adding or subtracting up top here. So looking here, we would make sure that we combine our 2 real terms, the 5 and the 7. So those 2 real terms, 5 and 7, got us a +12. And we always want to try to write the real component first in our complex number. And then looking at the imaginary parts we have here, the -2i and the +5i, once we combine those two things, we get a +3i. So this is what is considered a complex number. It's an expression that has a real part, which would be the 12, as well as an imaginary part, which would be the +3i. So always try to write it like that, with the real part first, imaginary part coming second. Once we get over here and we start to distribute, all we got to do is distribute this negative sign to the second set of parentheses. As you do that, all that's going to happen is our terms in there are going to flip to be the opposite symbol. So really we got 4 + 3i, now +1 minus 5i. From here it's the same thing, just combine their 2 real parts together. So as we look at the +4, +1 now, those both combine to make a 5. And my 2 imaginary parts here, 3i and a -5i. Both those would combine to make a -2i. So we treat it just like you would a variable. And it's not till we get to multiplication, right, and we start ending up with some exponents on the i's, where really we're going to have to do anything different than we typically do with any other variable. So let's look at multiplying. So looking at the first one here, you would distribute just like you normally would. So 5 times 3 gets me a 15. 5 times 2i gets me a 10i. There, that is our final answer, right? We're only going to change things that have I squared on them. So getting into the next example, here if you take 5i times 3, we get a 15i. Taking that same 5i times 2i, here just like you would with any variable, you want to add your exponents. So 5i times 2i gets me a 10i squared. So here's where it's key. Anytime we end up with an I squared, really that I squared is going to get replaced with the value of -1, if you remember back to the last page. So this is the same thing as saying we have a 15I plus here this 10 that was being multiplied times I squared. Really, we're replacing I squared with a -1. So you can see here, that's the only difference of kind of what we're doing today compared to what we were doing with any other variable. Is when we get an I squared, we replace that I squared with a -1. So in that case, what's going to happen is that once I multiply it times the +10, I'm going to end up with a -10. And then when I rewrite my final answer, I just want to make sure I put the real part first. So in this case, the -10 is going to come first, and then my +15I, or that imaginary part, will come second. So you always want to make sure your complex numbers look like that, with the real part first, imaginary part second. So let's get into foiling real quick on the next example. So multiplying our 4 different operations here. So do it pretty quickly. 1 times 3 is 3. 1 times 2i is 2i. Jump into the next one. -I times 3 ends up being a -3i. And for the last one here, this is where you want to add your exponents. We end up with -2i squared. So out of this, first we can quickly change our I squared to a -1. So replacing that I squared with a -1. So when we multiply those last terms together, what will happen is the -2 times the -1 ends up becoming a +2. So once we drop down our other 3 terms, now all we have to do is combine like terms, kind of like we did up above with the addition and subtraction. So I'm going to look at my real parts first. The 3 and the 2 in this case combine to make a +5. Then looking at the imaginary parts next, +2i minus 3i leaves me with a -I. So once again, final answers, you want to make sure complex numbers real first, then imaginary. So looking at this next one, just showing you can take 3 terms and multiply them together if necessary. When you do that, you would just want to multiply one at a time, so we wouldn't try to take all these 3 times each other at once, but we could multiply these first 2 terms together. Really gets us a -15 I squared. And then right away, before I distribute any further, what I can do is take the I squared and replace it with a -1, right? So as soon as we get this I squared, we can replace it with that -1 value. And all that's going to happen in that case is, once I multiply it times that -15, it'll then turn positive. So we still got to take that times the 3 plus 2i. So really we end up with a 45 plus 30i as that complex number. You can see here, all of our answers, right, should not have an I variable with an exponent other than 1, right? So any I that gets an exponent of a 2, we need to take that I squared, replace it with the value of -1, which really is just going to flip the sign of the coefficient in front of I squared. So let's look at simplifying some of these things. We're not going to do all these, but jumping to a couple of these. We'll do number 4 real quick. Let's look at number 4. Same thing, we got to start by doing our 4 different multiplication operations. 3 times 6 gets me 18. 3 times the -2i gets me a -6i. Now my 5i times 6 is a 30i. And 5i times -2i ends up being a -10i squared. So the more you do this, you start to recognize that this I squared, same thing as a -1. So really my last term there, instead of being a -10, it's really -10 times -1, which switches that to a +10. So now as I go to combine my like terms, I want to combine my real terms first. So the 18 and the 10 combine to make 28. And my 2i terms, -6i, +30i, end up making a +24i. So once again, final answer should not have I squared in it, just your I variable. Let's jump to down here. Look at number 7. We talked about this before, but now, anytime we have an expression that's getting squared, I know we were doing some exponent rules where we were just multiplying exponents, but that's only when we have singular terms inside the parentheses. If you have multiple terms inside the parentheses, really you need to take that expression and multiply it times itself. So that's 4 minus 2i squared. Really tells me I'm taking the 4 minus 2i and multiplying it by itself twice, right? So here we end up with the same expression written out twice. Now we have 4 different multiplication operations to do. So 4 times 4 is 16. 4 times negative 2i is 8i, negative 8i. Negative 2i times 4 is another negative 8i. And the last one here, negative 2i times negative 2i, ends up being a positive 4i squared. So don't forget to add the exponents if we're taking I times I. So really it's just the I squared term that we need to then go change. So replacing I squared with negative 1, our last term becomes a negative 4. And then now we can go combine our like terms. So the 16 minus 4 for the real component of our complex number gives us a 12. And then the negative 8i minus 8i, right, gets us the negative 16i. So just remembering to, when multiplying, add exponents, right, if you're taking a variable times a variable. And anytime we get I squared, replacing it with a negative 1. Let's jump to this last one here. Sometimes people get thrown off here. This last one on number 9. So the first one is just this distribution, right, as you start with your order of operations. So really we end up with 3 plus 3i. But recognize the sign here between these things is not multiplication, right? We have subtraction happening. So really in order to make that happen, we can just distribute into the second set of parentheses. So that gets us a negative 5 and then a positive I. So really we're not foiling in this case on number 9. Really we're just distributing 3 to the first set of parentheses, distributing that negative 1 really, which is the same thing as subtracting, right, to the second set of parentheses. And now we can just combine our like terms. So combine the real terms again. 3 minus 5 is a negative 2. 3i plus I gets me a total of 4i. Real part first, imaginary part second. So when we look at dividing or problems with fractions here or division, just like we can't have radicals in the denominator, we really can't have I in the denominator either, because I really represents a radical, right? So I is representing the square root of negative 1. So once again, you can't have that I in the denominator. So the easy one is when there's only one term in the denominator, so just a monomial in the denominator. All we really have to do is then multiply numerator and denominator by I. So that one's not too terrible. Once you multiply the numerator and denominator by I, gets rid of those I's in the denominator, which you'll see. And then similar to what we were doing with our day 3, once we have 2 terms in the denominator, here what we have to do is multiply by the conjugate of the denominator. So same terms, opposite operation in between. So we'll do a couple examples of each. So looking at these first 2, 10 and 11, both just as you look at the bottoms of those fractions, right? Just one singular term, no addition or subtraction happening in the bottom of either of those. So those monomials, right? All we got to do to get rid of I is multiply top and bottom by I. So just a reminder, when we multiply fractions, we're multiplying straight across the top. So 5 times I is just 5i. On the bottom, 6i times I ends up giving us 6i squared. So remember, for the I squareds now, we're replacing that with a negative 1. So really our denominator in this case ends up becoming a negative 6. So we end up with a 5i over negative 6. And there you can see the whole goal was to get I out of the denominator, right? So looking at it, we're trying to make sure that we don't end up with any radicals in our denominator, and really I is representing a radical, so we can't have I in the denominator. Jumping to the next one, we have an expression up top, which is okay to have 2 terms up top. Really, you're focused on the bottom to determine what you're going to multiply by. So as long as there's just one term in the bottom, once again, you're just multiplying top and bottom by that I. So up top, we got to remember to multiply it times both terms. So here, when I do it to both terms, I end up with 2i minus 6i squared. On the bottom, 3i times I gets me a 3i squared. So this time we see I squared appear in a couple different places. And in both places, we want to go replace I squared with a negative 1. So really, looking at simplifying it down, so the 2i up top, the negative 6 times negative 1 is going to get us a positive 6. Then underneath, we got 3 times negative 1, which gets me a negative 3. So the only thing you want to make sure you do is rewrite the top so that it looks like a complex number. We have our real part first, imaginary part second. And then from here, like we did with our radicals, if we could reduce our coefficients, we would reduce our coefficients, right? So focusing on it. If you have more than one term, really, you need to check to see if there is something that goes into all three of them. In this case, nothing will go into all three of those values, 6, 2, and -3. So we're gonna leave it just like that. Let's jump to a couple of these conjugate problems. I'm just looking at number 13 here. You can see that we have two terms in the denominator, right? We have two terms joined by subtraction. So in order to get rid of our I in the denominator, we're going to have to multiply top and bottom by the conjugate. So the conjugate would be the exact same terms, opposite operation in between. So in this case, we're multiplying both by 2 plus 5i. So we can do up top first. Just looking at it, 7i times 2 gets me a 14i. 7i times 5i gets me a 35i squared. So we want to continue to just simplify the top real quick. The I squared we know is going to switch to be a -1, which is going to change our second term to be a -35. I'm going to go ahead and reorder that now. So I'm going to put the -35 first and then the positive 14i second. So now down below, we talked about conjugates. I'm going to kind of take a shortcut, and I'll show you how the shortcut works here as well. But really, we have two terms times two terms. So 2 times 2 gets me a 4. 2 times 5i is 10i. -5i times 2i is a -10i. And then -5i times 5i, -25i squared. So once again, the middle two operations, right? Anytime we multiply conjugates, we'll cancel out. And then really, the I squared we are replacing with a -1. So really we end up underneath with a 4. Once we take the -25 times -1, that becomes a positive 25. Adding those together, we get our denominator, which would be a 29. So once we get our denominator, we're checking to see is there anything that goes into all three of those coefficients. In this case, nothing goes into -35, 14, and 29. So that's as simple as that one can get. Jumping to the next one, on number 14, same idea. So this one's a good example because you don't want to change your terms at all. All you want to do is change the operation in between. So it's still going to stay at -2 first. All I'm switching is the plus sign in front of my second term, changing it to a positive I. So really keep the first term the same. All we're doing is switching the operation in between. So this time we're multiplying top and bottom by -2 plus I. This time we got two terms up top as well as two terms down below. So really up top we're definitely going to have to FOIL do all four multiplication operations. So 3 times -2 gets me a -6. 3 times I, positive 3i. I times -2 is -2i. And I times I gets me an I squared. So as we look to simplify that one, the I squared, right, is going to switch to be a -1. If I combine that with the real part that's already there, -6 and -1 combined to make a -7. 3i minus 2i ends up giving me just a positive I. So there's the numerator simplified. Now we got to do the denominators. The denominator is really where we can really start to take a shortcut if we wanted to, since they are conjugates. So -2 times -2 would give me a positive 4. And then really I know that these next two will cancel out, right? So if I do -2 times I, that's a -2i. -I times -2 is a positive 2i. Those things would cancel out. So really I'm just focused on this last one here. -I times I gets me a -I squared. So that's going to become a -1. But really the coefficient out there was already a -1. So -1 times -1 ends up giving me a positive 1. So once we add those together, we would get a positive 5. So once again, the whole goal, as you look at all three of these answers, right, is to get I out of the denominator, since I really represents a radical, and we can't have any radicals in the denominator. So you can use the remainder of class today to work on that last assignment, 2.6. And then if you have any questions, feel free to shoot me a message in Canvas or send me an email.